Hello everyone, let's try to have another civil engineering licensure examination PSAD board problem. And in our session for today, we will concentrate more about reinforced concrete design. And this is now our Psad board problem number 5. Let us start solving a problem. And this is our C board problem in this session. A reinforced concrete beam 300 millimeters wide has an effective depth of 460 millimeters and is reinforced for tension only, assuming F prime of C equals 21 megapascal and Fy is equal to 345 megapascal. Determine the balanced steel area in square millimeters. Let us now start solving this given board problem. For our solution process, in order to determine the balanced steel area in square millimeters, we have actually two steps. And the first step, that is to solve for the balanced steel ratio first. While we already have that, we can then proceed to the next step, and that is to solve for the balanced steel area. Let us now first solve for the balanced steel ratio so that we can solve for the balanced steel area. In order to solve the balanced steel ratio, this is our formula. Rho B is equal to 0.85 F prime of C beta times 600 all over Fy times 600 plus Fy. But before we start the solution process, let us not forget this. We can use F prime of C equals 21 megapascal, and since it is less than 30 megapascal, we can now actually compute for our balance steel ratio. Why? Because we already have a given for beta, that is 0.85. Take note of that. For the beams, we always use beta as 0.85. And then our Fy value is equal to 600 megapascal. Our F prime of C is 21 megapascal. Then we can do now the direct substitution so that we can solve for the balance steel ratio. Our balance steel ratio is now equal to 0.85 times 21 times 0.85 times 600, and our denominator will be 345 times the bracket of 600 plus 345. Finally, our calculated value for the balance steel ratio is equal to 0.02792. We can then now solve for our balanced steel area as a question to this problem. And the formula that we're going to use for the balanced steel area, A sub SB, is equal to rho B times BD. Given this formula, we can now actually compute for the balanced steel area. Why? Because we have a given 300 millimeter wide, that is our base, and the effective depth of 460 millimeters. And we have already calculated for the balance steel ratio, that is 0.02792. So all we have to do now is direct substitution to this given formula. Balance steel area is equal to 0.02792 times 300 millimeters times 460 millimeters. Finally, our final answer to this is 3,853 millimeters square. In addition, allow me to read about balanced steel ratio. In reinforced concrete design, ROBI or balanced steel ratio represents the balanced steel ratio, which is the proportion of steel reinforcement where the concrete and steel are expected to reach their maximum strain simultaneously at the point of failure. It essentially indicates the amount of reinforcement needed for the concrete and still to fail at the same time under the ultimate load. While on the other hand, the balanced steel area represents the amount of steel reinforcement that will cause the concrete to reach its compressive strength or crushing, and the steel to yield in tension simultaneously under the ultimate load. Again, our final answer to this given problem are balanced steel area 3,853 square millimeters. Thank you very much and God bless us all.